Sixerbot says.
Welcome. Stream starts in 5 minutes.
We're not doing that. We'll see if stream survives this. I don't know how long I was gone, but I forgot that I don't actually use a cable going up there, but I'm using one that's on the floor. Oopsie. So she fixed that. Meaning I have to remove everything on the cupboards. I have to open all the things here and put a new cable in there. Since our rebuild of the network, it's not rebuilt in here yet. And I've been like lazy. Also, I've got a tiny hole in the wall, so I've like pushed through a TV antenna and whatever else it is.
T-minus 4 minutes.
It's not a lot of space for a network cable, so I'll have to try to take a tiny file and try and saw through that metal to make another one fit. I use a drill to start with. With 2 cables there, I can't do that. They go like all over on the tough metal, like holding up the walls things. So the walls are stuck on metal frames, and they are by the roof. And when you want to put cables through, it's not easy. So maybe I'll just open that up now. So yeah, I killed stream. I was kind of thinking, I didn't think there was anything in the kids' room, but that's where I connected it. That's stupid of me. I'm actually thinking of doing it again right now, to just move it to the switch, which is shorter distance. And it's also actually been on the floor, on the upper hallway for quite some time. And now timer, we were already 15 minutes in the last hour before no internet for the kids. But my other kid's already in bed, so it doesn't matter for him yet. I need to fix the configuration. So I kind of already said what do we have, right? Our hardware. But I don't want to configure it on stream anyway, do I? Let's try and work on this a bit more instead. I kind of really want to do the other stuff too, though. We could just swap to hardware. Let's do that. So, and since this is the first time I'm using a rotary encoder, I will go AI on it again, I guess. So why Google? Because Google is better. Okay, rotary encoder, ESP32. Why not have some more tabs? So ESP32 IO. Whatever, let's do recommended. I haven't heard about the site before. It sounds interesting. So you will learn how to use a rotary encoder with an ESP32.
Stream about
Here's
to start.
what
1 minute
we'll
left.
learn. And these are what we got in the mail today. Oh? 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 I'm like, oh, several times here. So when people drop out of stream now, I'm like, did I kill stream again, you know? It's kind of what I think. Yeah. I'm sorry for the black one. I'm just trying to figure out what happened when the camera because it shouldn't be affected. I didn't kill the Wi-Fi yet. And this should be connected by Wi-Fi. And the phone is not bad. So I don't know why, but it's working. So I didn't kill the Wi-Fi. Most definitely didn't kill the Wi-Fi, so I don't know why. It might just have been that it's starting to bug. So here are the rotary encoders. Let's say that we want the one with the short bits. So it has what I assume are ground on the sides. There. And then you have 3 pins on this side and 2 on this. And we will soon know if these are possible to push into the breadboard or not. So let's put one of these on here, right? So we get a little nicey feel of the rotating. Or maybe we won't, because it was so hard to push. Get rid of it again. So let's just see if we can push this in. I don't care if this is the right spot or not. Yeah, maybe. So the legs are not long enough to go down. So we need to make a bit of a soldering thingy. Put pins on there. And I had pins somewhere right here. But let's read off it first. We also have this one that has ships and stuff, but I don't kind of like this. I don't like this. Because it takes more space, right? And I only have one, it has the wrong top. So I bought these for a reason. Because I want the nice to turn ones. So yeah, let's put all the... I'm changing my mind. I like the feel of these better. Because you can put your full fingers around the fingertips and turn it. And they're the same for the rest, it's just the length. So unless we put a knob on there. Yeah, so we need to do some soldering there. We also have the SE reader. So yeah, as it's getting later, I can't select text. That's annoying. Can't select text. What's up? Can't select text. Why?
/*.
This is text.
*. This ESP32 code is created by ESP32IO.com. *. This ESP32 code is released in the public domain. *. For more detail, instruction and wiring diagram.
So it's not
visit
actually
http
code
URL.
except for this.
# include easybutton.h. ESP32 rotary encoder. In this guide, you'll learn how to use the rotary encoder with an ESP32.
Well, let's do that.
Here's what we'll learn. 1. What are differences between a rotary encoder and a potentiometer?
Text.
2. How the rotary encoder works. 3. How to connect the rotary encoder to the ESP32.
It's up here.
4. How to write code for the ESP32 to read the direction and position from the rotary encoder without interrupt. 5. How to write code for the ESP32 to read the direction and position from the rotary encoder with interrupt. Hardware used in this tutorial. 1 times ESP-RAM32 DEB module. 1 times USB cable Type A to Type C, for USB APC. 1 times USB cable Type C to Type C, for USB-C.
Yes, gubben? Du börjar prata. Okej. Vad är det? Vad bra. Passa på att titta på YouTube eller något sånt så länge som kräver internet då. Vill du titta på internet eller vill du gå och sova? Vill du titta på internet en liten sista stund eller vill du sova? Va? Nej, jag tror inte det. Kanske 23:20 eller så. Du kan fortfarande koda. Du kan göra coding. Jag vet, jag ska sova snart också. Okej. Sen finns det något som heter ljudböcker också, Labban. Man kan lyssna på utan internet. Nej, inte riktigt. Lite till. Men det har ingen betydelse om jag streamar eller inte, Labban. Jag kan hjälpa dig med saker.
Adana Starcio says,
kan jag göra med dig.
What lab are you doing?
Yes. Jag ska gå och avsluta, Labban, så jag hinner det. Jag älskar dig. Okej. Jag vill gärna att du ska hämta vatten själv. Okej. I'll be right back. Du får gå och tvätta dig verkligen. Vänta där så fixar jag vattnet. Ja, pappa på det. Gå ner. Okay, I'm giving my kids some water. So first they have a really turn into a bathroom mode. So it's like, oh my God, before I know. Så det bara varsågod. Så nu måste du kunna gå och hämta själv. Okej. Like. I'm doing it because he's got sleeping problems. And it's connected to his autism. So that's why it's want to get away. So we're doing this as a project. And we can actually connect power. Let's do that. Power cable. So we got a new ESP32s in the mail. And let's see here. There it is in the drawer. So if we connect this here, this one will start scanning for networks. There. And if I wait 30 seconds, it will scan again. And hopefully find more than 3. But that's why we bought new ones that can have antennas. I have one with an antenna, but apparently it didn't work. But for now, we're going to test to make a menu with a rotary encoder, and that's why we're checking out the rotary encoders. So that's what we're doing. So I'm gonna disconnect this for now. And I'm like, didn't I have more stuff on this board? But I guess this is the one that's filled up with stuff. Right? So this one has a menu. I think I might have put some other program on there. Or maybe it's just the keyballs popped up. These are not even actually pulled down, and now this is falling off. Yeah, and I did this, right? Because this is falling off without me touching it. And someone asked how they look on the bottom, so I thought, why not? Why not show? So we'll have to put some tape or something on the bottom. So this is for controlling it with buttons, menu on the screen. And then this is replacement, the slicer. So let's see. Yeah, so maybe in the soldering bar. Yeah, here we got some electric tape. So let's put some of that on here. So I don't really like this, it's so sticky. So I mostly used it for building martial arts training things because it's stretchy. So it's not very good with electronics. So yeah, it kind of shrunk there. Stretched it too much. And it's not really sticking, is it? Maybe I should just screw this onto a surface. It has the holes here. I got the best idea. I've got thin plexiglass. We can have plexiglass under it so I can show people how it looks. Because this is not gonna stick, is it? It's like, no, not sticking. So this one is a bit sticky. You can hear it, right? So this will probably stay if I push it back, which this bit just fell off. Did it throw it? Probably. I know the speed of the stream is like odd, and also I might just continue coding stuff when I stop streaming, because I kind of think that I need to be not evil mom shutting off internet and keeping streaming. Well, I actually should sleep this up too. That's not a good example, is it? So let's forget about the one that requires care, and let's just focus on the rotary encoder for now. And I tested connecting it like this. It would fit these popping in the middle, but these legs are not long enough to actually stay. But that's because these plastic thingies. So the plastic is stopping it going in. So we can cut the plastic off if we want to, or melt it off. But I guess it will, yeah, I don't know. Why would we even want the plastic there? So don't have a good knife. And this feels like not that sturdy plastic. Let's try this bad one. So I bought 10. Yeah, I'm just cutting straight into it. So if we remove these, the middle one being the most problematic one. So there's a little blue here. so we have more in case we were to regret the decision. So the middle bit might fit in the hole too. There's just a tiny bits on the corners. I'm actually going to show you what it looks like. So, this is it, and you can see those are the tiny corners. I started cutting on that one. And the bit in the middle might fit with these in the hole, at least if we make it tinier, and I already got rid of one of these corners here. There's some stuff left there though. So let's actually zoom this so I can see when I'm at there. And let's pop this up big. So yeah, so I want a tiny thing like a scalpel for this, really, right? This is too big. No. So there. So there's still quite much of it left. So I don't want to put any pressure on the bits, the metal pins here. These, we need to be careful. So that's why it's hard to get this to fit. So that one's kind of off. Though there's a little bit on the side there too. Didn't really see that when I was just looking in the eyes. So try not just to do it, but to show it too. Yeah, let's get rid of that. Yeah, I think I will stop streaming and I will code offline for after midnight, as this is the first day my kids are not allowed internet after midnight, and one of them is already sleeping. So, well, or he's been in bed at least an hour. So, last corner. Let's see. Then I think I will have to peel off the bits like this-ish on the middle. So We got lots bits of plastic here. Yeah, I stopped the TTS. Let's start it.
PC. 1 times rotary encoder. 1 times breadboard. 1 times jumper
We can
wires.
multitask.
1 times recommended, screw terminal expansion board for ESP32. 1 times recommended, breakout expansion board for ESP32. 1 times recommended, power splitter for ESP32. Or you can buy the following kits. 1 times Diabless ESP32 starter kit,
Or we can
ESP32
just
included.
play.
1 times Diabless sensor kit, 30
Not
sensors
care.
/displays. 1 times Diabless sensor kit, 18 sensors
They want to
/displays.
sell stuff?
Disclosure, some of the links in this section are Amazon affiliate links, meaning we may earn a commission at no additional cost to you if you make a purchase through them. Additionally, some links direct you to products from our own brand, Diabless. Introduction to rotary encoder. A spinning knob, like on a radio, can send signals that turn into electricity. It helps us know how much it turned and where it's put.
Get rid of
there are 2 main types. 1. Incremental encoder. This one uses quick signals to measure how much something changed its position. 2. Absolute encoder. This type gives a secret code for each spot, which helps us find where something is, even if the power goes away. This lesson is mainly about the first type, the incremental encoder. Rotary encoder module pinout. A rotary encoder module has 4 pins. 1. CLK pin. Output A is the main pulse that tells us how much rotation has occurred. Whenever you turn the knob by 1 to 10, click, in either direction, the CLK pin outputs a signal that completes a full cycle, low rightward arrow, high rightward arrow, low.
I put the knife
2.
away, but I'm
DT
not
pin.
actually done.
Output B acts like the CLK pin but outputs a signal lags behind CLK signal by 90 degrees. It helps us figure out the direction of rotation, clockwise or anti-clockwise. 3. SW pin, comes from the encoder's button. It's normally open. When we add a pull-up resistor to this pin, the SW pin will be high when the knob isn't pushed and low when it's pushed.
Screen,
4.
and this is not
VCC
rotary.
pin, plus needs to be connected to VCC, between 3.3 and 5 volts.
This is a
5.
module.
GND pin, needs to be connected to GND, 0V. Rotary encoder vs potentiometer. You may confuse the rotary encoder with the potentiometer, but they are distinct components. Here's a comparison between them. 1. Rotary encoder is like the modern version of potentiometer, but they can do more things.
Are
2.
they similar?
Rotary encoder can spin around in a full circle without stopping, while potentiometer can only turn about 3/4 of the circle. 3. Rotary encoder outputs pulses, while potentiometer outputs the analog voltage. 4. Rotary encoder is handy when you just need to figure out how much the knob has moved, not exactly where it is.
We'll just have to measure it.
Potentiometer is useful when you really need to know exactly where a knob is. How rotary encoder works. Inside the encoder, there's a little disc with slots that's connected to a pin called C, which acts like a shared ground. You've got 2 more pins, A and B. 1. When you turn the knob, pins A and B touch that shared ground pin C.
So we can stop that. Module. We don't have a module. I don't want to use a module. That's why we don't use the one I already had, because that was a module. So I have 2 rotary encoder modules. They don't have the nice thing there. So we want to go straight to it. So let's see what this says. Yeah, let's just do a quick AI question because we have limited time, and this is a Google way to Google for when you want details, like we don't want module in there in the search. So I want to connect my rotary encoder, not a module, to my SP32. Please help. Start with exactly how a rotary encoder works. That couldn't be misunderstood, can it? Got it. So let's TTS this while I actually type.
Got it? Let's start from the basics of how a rotary encoder works. A mechanical incremental rotary encoder, the common cheap type with 2 output pins A and B, plus a push button if present, works like this. Inside, there's a disc with contacts and 2 channels, A and B, offset 90 degrees apart. As you rotate, the contacts open/close in a repeating pattern, producing square waves. The 2 signals are slightly out of phase, called quadrature. This lets the ESP32 detect both movement and direction. If it changes before B, rightward arrow rotation is clockwise. If B changes before A, rightward arrow rotation is counterclockwise. Each step, detent, typically gives 1 to 4 signal changes, depending on encoder design. The push button, if your encoder has one, is just a momentary switch between the middle pin and ground. Backhand index pointing right to wire it to the ESP32. Common, C/GND pin of encoder, rightward arrow ESP32 GND. A pin rightward arrow ESP32 GPIO, with internal pull-up enabled. B pin rightward arrow
Middle pin
ESP32
ground
GPIO, with internal pull-up enabled.
then.
Optional, switch pin rightward arrow ESP32 GPIO, with internal pull-up. Would you like me to continue with a step-by-step connection diagram, pinout example, before we move on to code handling?
Let's just write this first. Bring one side and 2 on the other. It has button functionality. Perfect, that matches a standard 5-pin mechanical rotary encoder with push button layout is like this. 3 pins, left pin channel A, middle pin common ground, right pin channel B. 2 pins, one side of the button, other side of the button. And I really need my, where is it? My multimeter, it's just gone. Can't be gone. So I don't think my kid's gonna come and say, Mommy, it's midnight now, we're supposed to turn the internet off. And might I forget it? Yes, right? So we have to check time too. So I already checked these drawers. Nothing there. Nothing there. This one I didn't look at. Oh, there we have anti-static bags, zip bags, and parts. Not in the soldering drawer, it wouldn't fit. Not in the power supply drawer, which I should close again. Let's see if I can show this here. I showed it because of something. It go there. Yeah. It's not supposed to be on that side either, so kind of good it's not. It's supposed to be here. In the drawers. I'm gonna go get Austin my hubby if he borrowed it. But he hasn't said, no, it's here. I found it. It's just at the very, very bottom. Found it. So, with our new little cable that we made, which is useless for this purpose. So, we just made this. These. So, instead of when you're measuring on a breadboard, this is very nice. So we made these the other day. Nice. Nice thing. So there. Now I want ones with hooks. Hooks. We can keep these attached. So, yeah. So these are with hooks at once. So I think I just cut off these and put these on instead. It's very nice when you're lazy. I mean efficient. So we're going to check if we can short the button. So maybe microscope is better for this. So let's see. Over here. So we have the 3 pins over on this side. So if we connect one of these to one of these, like that, little thing like that, and then we connect the other one like this, there, and I'm gonna put it to beep. So if I click the button now, no. And to check the beep. So most definitely, let's keep the button pressed and test the legs. Yeah, I took the wrong one. I'm supposed to do that one. And this one is supposed to be the beep. I'm just on the wrong side. So when I click the button here, now we have a beep. So button is on that side. That side is for. Very nice. So yeah, I still want it on the breadboard, don't I? Left pin. So I didn't hear all of what I said, but something about maybe this goes in one direction and with this signals in the other direction, and you get like blips for signals. Let's actually listen to this because I'm too tired to read it again, so I'm gonna just.
Got it? Let's start from the basics of how a rotary encoder works. A mechanical incremental rotary encoder, the common cheap type with two output pins A and B, plus a push button if present, works like this. Inside, there's a disc with contacts and two channels, A and B, offset 90 degrees apart. As you rotate, the contacts open/close in a repeating pattern, producing square waves. The two signals are slightly out of phase, called quadrature. This lets the ESP32 detect both
I need
movement
to
and
read
direction.
it myself.
If
I'm
it
too
changes
tired
before
to
B, rightward
listen.
arrow rotation is clockwise. If B changes before a rightward arrow rotation is counterclockwise. Each step, detent, typically gives 1 to 4 signal changes, depending on encoder design. The push button, if your encoder has one, is just a momentary switch between the middle pin and ground. Backhand index pointing right to wire it to the
I feel
ESP32.
stopping the
Common,
TS.
C/GND pin of encoder, rightward arrow ESP32 GND. A pin rightward arrow ESP32 GPIO, with internal pull-up enabled. B pin rightward arrow ESP32 GPIO, with internal pull-up enabled. Optional, switch pin rightward arrow ESP32 GPIO, with internal pull-up. Would you like me to continue with a step-by-step connection diagram, pinout example, before we move on to code handling?
No, I'm gonna have to read it when you're finally quiet. Mechanical incremental rotary encoder. Common chip type with two output pins AB plus a push button. If present, works like this. There's a disc with contacts and two channels A and B, offset 90 degrees apart. As you rotate, the contacts open close in a repeating pattern, producing square waves. The two signals are slightly out of phase. So I know that fancy electronic, expensive, very expensive machines have bad rotary encoders, right? So maybe it won't be good, but hopefully we'll be better than them because I don't know what they're doing. They're just bad. So as you rotate, contacts open close in a repeating pattern producing square waves. The two signals are slightly out of phase, called quadrature. This lets ESP32 detect both movement and direction. If A changes before B, rotation is clockwise. If B changes before A, rotation is counterclockwise. Each step detent. typically gives 1 to 4 signal changes depending on encoder design. The push button, if your encoder has one, is just a momentary switch between the middle pin and the ground. So this is not what we have done. So let's skip its pin stuff. Perfect, that matches standard 5-pin rotary encoder. So let's make some notes. So code for thingy. Where's code for thingy? Hardware. And again, I put this under platform IO, so let's make a new note under platform IO. Let's do rotary encoders. And I didn't already make one because I didn't like research this at all yet. Mechanical incremental rotary encoder. Inside. Well, I'm gonna cut away bits of that. So I know that's not. So we'll have to fix it later, but 5-pin mechanical rotary encoder with push button, the layout. So the wiring, I'm not really there yet. Yeah, let's see if we can make it. No, we can't. How to delete the lines manually. Probably if I paste it in Notepad. Why all the double lines? A mechanical incremental rotary encoder. Let's just skip that. Inside there's a disk which contains 2 channels A and B offset 90 degrees apart. As you rotate, the contacts open close in repeating pattern producing square waves. The 2 signals are slightly out of phase, called quadrature. This allows the ESP32 to detect both moment and direction. If A changes before B changes before A, each step detent typically is 1 to 4 signal changes depending on encoder design. Standard 5-pin mechanical rotary encoder with push button layout is usually like this. 3-pin encoder core left. So why is this one less indented? Well, middle ground, right pin. I mean, right and left is totally useless here, as we could be looking at it from this direction or this direction. I'm guessing from the upside, which is not what I would do first. So 2 pins, button side. 1 pin, yeah, obvious what those do. So electrical, the 3 pins are for rotation, and the 2 pins are for push button. So repetition in this way is just annoying. Do you want me to draw you a map? 32, 33. So draw you a map, and then it's saying what things. So I already use some pins, and we'll also add a SD card. Feel free, but I don't really want it to give me suggestions because I prefer doing that from Platform.io. So let's check out Platform.io first. Let's go the right way and not get some crappy code in there and crappy pins that won't work. So better we tell it what to use than the other way around. And I'm kind of thinking that might be the all the info we need. So we want a library that has this. So first, what I'm looking for here, the TFT also has a SD card. So that's why I'm thinking there might be examples using this. Yeah, maybe not. PNG images. PNG decoder library. So these will not be stored somewhere else but on the device. Smooth graphics sprite, custom diagnostics, touch. Yeah. So let's close that. So this one we actually don't tell pins because we're using the default pins, which is kind of cool. Kind of cool. So there's some data in there, though. Extensions. TFT tools user setup. Yeah. 42. So here we have the TFT pins. So this is the one I'm prioritizing now. And I don't know, maybe we should just write down all the pins because it is not explicitly written down anywhere. So pins in use. I'm typing in the C code. Let's do actually a star there so we get a little space to write. So this is where the rotary encoder actually fit quite well. Like this. It has the right width for the legs. Come on. Hop over to the right space. So the thing that stops it from going down was the plastic bits, but we still have a bit of plastic there. So maybe let's, yeah, I'll just move it out of the way so we can do this. So this one, the TFT here, it has these pins too. So this is for the SD card, right? So the SD card is very short. Nah, it's just scratches in the plastic. Just scratches in the plastic. Good thing you can focus on different heights here. So, but maybe this is a good zoom level for this. So we want to see exact details on what pins we use here. So let's start on this side. And I'm not sure if this is a good idea, but we're using 23 for green. Let's do 23 green first. 23 green, and because it will be connected to the TFT display, and it's the only thing using green. No, yeah, 2 cables that are both green are going from 23. Then we don't have anything, meaning pins 22. Let's do 22 free. And then we have a TX and RX that I'm kind of assuming we're not going to use. But let's put TX, RX. We might actually use them. And then 21. Yeah, this needs to be straight ahead for this to be good, right? So we can even remove the desktop because it kind of doesn't help. So let's align, zoom, and move the board. So now you can see it's straight. So 21 is also free, nothing in the holes there. And then there's a ground. So 21 free, GND. And we started with GND2, so I'm kind of putting all of the pins down like this. And then we have 19 white and 18 gray. 19 white, and it's midnight. Maybe this isn't that fun to watch anyway. I can continue this on my own. 18 gray. I'm sorry, people, but I promise to cut the internet for the kids, and I don't want to do it for them, and they see me streaming still. It's not a good start for a new thing. I'm saying like the whole family needs to stop and sleep good hours. Let's do like 5 minutes more, and my kid will get a little soft start because it's the first day. So 18 gray. We can check these and then we'll stop. And then we have actually 2 blues here. So we're going to call them different things. So after 18 there's 5, 17, 16. I think it's 4. And 0, which is like special, right? If it's actually 0. I don't trust the text anymore after reading 16s15 for quite some time there. So 5 is blue for follow the cable all the way over here. It is blue for yeah. So I had an image for this up on my phone before. So I'm deciding at 15 costs. I'm gonna do the raid. So I'm gonna check out a bit, pre-check here. So we got the usual guys streaming. Just opening streams, muting, Opening my own because we want to grade from there. Oh, the tiny fly. It's like a banana fly. It sat on my arm and tickled. We also have Adam. Adam learns live. Yeah. Why not do something different? We've been doing different things today. But it says one person is in here, so maybe it's not much of a raid. Yeah, tech problems. If you kill your internet, you don't have internet. You can't kill your stream, right? So, hello, one person. Also one on YouTube. But I don't trust those numbers, though. We don't know. We don't know. At least I was in the list. It could have easily bugged out. Let's see now. Your package has been delivered. Send you a connection request. Yeah, I was going for an image. Come on, go for the image. Food, lots of food. Oh, work. Meaning this is electronics work. Come on, come on. Oh gosh. Oh gosh, this is so many images. Oh no, now we're here. My electronic stuff. Found the image. There. So now we have this. So that's a touch. That's actually the touch is fourth pin, meaning it is the CS. Yeah. So oh. Did I even open those? There. So I'm thinking I might have missed a stream I wanted to see yesterday, but now I know I missed one today too. Because so obviously I missed cybersecurities. Yeah, we won't have time. I'm thinking 4 minutes. We won't have time to do all this in 4 minutes. But let's continue for 4 minutes. So 5 is green. Let's do one at a time. Green is not the first pin. One, that's the white. We have white, green. So green is DIN. So it is touch DIN. It's also called T outright, that's touch. And then we have white on 19 being the second pin, which is touch DO. DO, data out and data in. And then we have gray on 18, which is the fifth pin, meaning it is clock, touch clock, touch clock. There. Goody good. And then let's see what we have after 18. So it is here, 18. After 18, we have 5, which is blue. So let's call it blue 1. And it is touch CS, right? Because it's select. Yeah, touch CS. Because that's the one it's got a unique one of. The first one is TIRQ. and it goes to the first side here, the brown one. It goes over here. So we'll do those last. So let's go continue on this side here. After this, we have 3, 17, and 16. So those are free to use for something. So let's type 3 here. 3, 3. And let's also put 3 on TX and RX because they are free. Kinda. I'm assuming they're used when uploading and when setting, when using serial internally on it. Let's not type 3 there. Let's just lying. The USB uses TX and RX. I'm sure. Ground. So as this is this specific ship, I want to put all the ground pins there as we can use them for connections later, right? So 4 is this where we are now. Yes. So 4 is purple, possibly. So we have 1, 2, 3, 4 from the other side. 1, 2, 3, 4. That's resets. 4 is resets. But it is purple. I forgot the color. Purple. And time is 15. Yeah, my internal clock was right. So we got this down, and I'm going to continue making this list with what we have on this ESP. And I will also add the actual numbers of the pins for the ones that have names. Grounds are just ground. They put them in some places, which is nice. And I guess they're in between because they want to like remove disturbances there. Yes, I'm gonna continue a bit after I stop stream, but let's go raid someone. And let's hop over here, and it's still 1. Yeah, it kind of feels like it's not worth raiding, but I kind of said I would raid, right? We have to raid. Should we raid Adam? Yeah, it's funny though. It's truly a micro raid, but it will not. We don't know yet because actually, I don't think that number is correct. I think we have done one of the bugs. Do you know why? It's because I actually have the stream up twice, and I think it would show. I think it would show. So it might just be no one watching, or it might be people and it's just bugging. So Adam's kind of fun to watch. And I tested this game. Oh gosh, that's double. There. So let's put on the raid and we'll see if it's one person in there. So maybe if I do this. So let's put on the raid and we'll see if it's one. I'm curious. Will that matter? Let's also see if my TTS is on there. So obviously it's not the same number because that would be too large. Oh, I still have the projector too on, but I kind of want that one. Yeah, I'm gonna go kill internet. Well, not truly, but I won't be streaming for my kids' sake. So it is time. It is midnight, and I promise to not stream anymore. Or rather, I'm doing it. Oh, you can't raid? Okay, let's do Shy Hat. So. Oh, maybe he's stopped already. It's frozen. He's all frozen. Yeah, I think it's dead. I think it's dead. So what's Shyhead doing? Let's do a microwave to Thomas here. If I can copy, I can type it. I can type it. Raid. Thomas. So he does lots of Linux stuff. Panda said something about getting someone here was has follower or subscriber chat only. So we know that already. We have one person. And the other one says two. I don't care. I don't think it's one person though. But we did have the crash. Crashy crash. Well, can you call it a crash when you pull your internet cord out in the middle of stream? I guess not. I guess not. Manage your sub to my own stream. What happens? Sub anniversary in 8 days. You realize what I mean? I created this account in 8 days. No, I have affiliate anniversary. September 14. Look. And I've been streaming for 22 months as an affiliate. Gosh, time flies. Yeah, let's click right now before it's not possible. Good night, everybody. I'll continue this. So,
Well, somebody comes in that's not interested in listening, right? Some outside force. They have no intention to listen to anything you say. They're going to do whatever the hell they want. However, if I have 110 controls and they're all technical controls, the only option they have to go around those is to break them in some way, right? And this becomes the crux of the security matter. We're going to set things and we're going to do things on our systems, and other people are going to come along and try to bypass them or change them. They're either going to go through them, they're going to go up and around them, they're going to do something to them, right? So there's that. Anyways, all right. And then we said what types of controls and how do they relate to the above question. So it's that same idea, right? And some people have already been answering this. So you have good ideas to think about before you answer this. If you go and post in the Discord about it, you can also respond to them and say, hey, that's a good idea, or where did you find that? You know, whatever. Okay. Discussion post 2. Find a STIG or compliance requirement
yeah,
that
and
you
now
do
it says
not
2
agree is
viewers.
necessary for a server or service.
2.
Again, this is one
It's
of these
very
things that
funny.
ties back to this. Maybe you don't think any of the authoritative
Stop
ones
streaming.
matter.
Good
What the hell do we
night.
put a...
I'll
Why put a
continue,
banner
but
up?
I'm
They know
gonna
what they're
close the
going
room and talk
into.
to my kid.
Well, I don't know. Maybe it just reminds people that they're in a government system. But maybe you don't agree that that needs to be there.